Hello, Geometry. We have reached the end of Chapter 4 now. This is the last lesson in Chapter 4, so you're doing a good job. Proud of each one of you. This last one deals with the similarity, so we're putting in the dilations, but with the transformations as well. So similarity and transformations. The essential question, when a figure is translated, reflected, rotated, or dilated, those are the four types of transformations we're having: translations, reflections, rotations, dilations. Is the image always similar to the original figure? So we're just going to jump over from page 117, that's where that was, straight to 119. So a similarity, or vocab here, a similarity transformation, that has to be a dilation or a composition that includes, put a space in there for includes a dilation. Okay, remember a composition is one, two, or more. Dilation. So it could be a transformation followed by a dilation. It could be a dilation followed by a reflection. Those are all compositions. Okay, when you do one, then the other. Okay, similar figures. That's going to be figures that have some sort of transformation that can map one to the other. So, can be transformed from one shape to the other using translations, reflections, rotations, or dilations. Figures that can be transformed from one shape to the other using translations, reflections, rotation, or dilations. Remember, the translations, reflections, rotations, those are called rigid transformations because your shape stays the same size, same shape. Dilation is going to create these similar figures. Okay, similar figures, remember, can be two objects. A little bit more plain definition is two objects that have same size or same shape, different size. And I don't think that is a very good example of what I'm looking for there. Okay, maybe that one. So those two triangles have the same shape but different sizes. So when we're dealing with similar, we're dealing with things that have the same shape, different sizes. Okay? And two characteristics that are important for similar figures. Angles are the same. Angles are the same. So if this triangle, let's say this is 80 degrees here, if this is the corresponding angle, that would be 80 degrees. So angles are going to stay the same measurement. Okay, but the sides are going to be proportional. All sides are proportional. That means the same scale factor. So if you're, okay, all sides are proportional, same scale factor. So let's say this is 3, and then this is 6. So if this is 3, this is 6, that means your scale factor is 2, you're multiplying by 2. If this is 4, this has to be 8. If this is 4.5, this would have to be 9. So all your sides are proportional. Let me show you, like if I, here on Desmos, let's say I just draw a triangle. Okay, right now if I drag these points, these are not similar triangles. This one is different than this one, which is different than this one, and this one, this one, this one, this one. Okay, all of those are different. But if let's do a circle there, move that down a little bit, and I'm going to put a polygon inside the circle. Now, if I enlarge and shrink the circle, now I'm getting similar shapes. I get the same shape, but it's changing different sizes. And you notice if I measure the angle 61 degrees as I make it bigger and smaller, that angle stays the same. The same would be true here. And if I measure these are going to change, of course, because the lengths change. And they're going to be proportional. Okay, so that represents similar figures. This is not similar. Okay, let's get to the practice. We have two main things. It's basically drawing the shapes for transformations. So here you're taking the information and you're drawing the different shapes. This is a composition. And then here you're going the other direction. They're giving you the shapes, and you have to figure out how do you go from the one, the pre-image, to the new one, the image. Okay, so here we go. Let's start. I'm going to draw my initial one in black. So A is at 3, 6. B is at 2, 5. C is at 4, 3. And D is at 5, 5. So A, B, C, D. There's my quadrilateral. So the first thing we're going to do is a translation. It's going to go 5 units left and 3 units down. So I have A, I'm going to write this down here to make a table. A is 3, 6, B is 2, 5, C is 4, 3, D is 5, 5. Okay, now we have to apply x minus 5, y minus 3. Let's go with blue. So x minus 5 would be negative 2, y minus 3 would be 3. X minus 5, 2 minus 5 is negative 3, 5 minus 3 is 2. So these are my primes. A prime, B prime, here comes C prime. 4 minus 5 is negative 1, 3 minus 3 is 0, and then D prime, 5 minus 5 is 0, 5 minus 3 is 2. So let's put those on. Negative 2, 3, negative 3, 2, negative 1, 0, and 0, 2. So it'd be A prime, B prime, C prime, and D prime. Okay, so I've drawn that shape. Now my final one is a dilation. I'm going to take these answers, these points here, and I have to do a dilation of 3. Okay, this is with respect to the origin, so everything is going to get 3 units further away from the origin. So I'm taking my primes. I'm going to come up with A double prime times 3, so that's negative 6, 9. B double prime is negative 9, 6. C double prime is negative 3, 0. And D double prime is going to be 3 times 0, which is 0, 3 times 2, which is 6. Okay, so negative 6, 9, negative 9, 6, A double prime, B double prime, C is negative 3, 0, and D is at 0, 6. Okay, so those lengths should have gotten twice as far from the origin as what they originally were. You can use your points that are on the x and y axis to very easily tell that. To tell that with the A and B's points, you'll probably have to use a distance formula or make a right triangle. Okay, but every single shape should be similar. Okay, we should have similar shapes. The first one should be congruent because that was a rigid transformation, and then that one should change there. Okay, so you get the idea. What's going on with that is you just do the first application, the first transformation, you take those answers, do the second transformation. So number 2, you're doing a dilation first. I think we'll skip 2 and maybe we'll try number 3. You're doing a dilation first, and then you're reflecting it in the y-axis. Okay, this dilation would be something that's making it smaller, a reduction, because you're multiplying by 1/4. Okay, number 3 has a rotation, 90 degrees about the origin. So we'll review those formulas. 9, 6, there's x, 3, 3, there's y, and 3, 6, there's z. So x, z, y, x, y, z. So I'm going to start with our rotation. So x is 9, 6, y is 3, 3, z is 3, 6, and 90 degrees about the origin. The rule for 90 degrees is if you have x, y, it's going to go to, let's see, I got to think about this here. That's 3, 6, negative 6, 3. So the opposite of x, y. I could have looked it up, but I didn't want to right then. I'm going to try to figure it out. Okay, so x prime. X prime would be, the opposite of y. Opposite of y, x is what that should be. You're probably correcting me right now. Mr. Leitner doesn't know what he's doing. Okay, so opposite of y, x, so that'd be negative 6, 9. Let's check that, make sure my formula is right. Negative 6, 9. Okay, so I think if I go from here to here, here to here, that looks like a 90-degree rotation. That's my checkpoint there. That should be a 90-degree rotation through the origin. Okay, y prime would be at negative 3, 3, and z prime would be at negative 6, 3. So there's x prime, y prime, z prime. Okay, so there's my 90-degree rotation. Now we have the dilation multiplying by 2/3. 2/3 x and 2/3 y. So 2/3 times negative 6. That's negative 6 divided by 3 times 2. So that would be negative 4. And then 2/3 y would be 6. Negative 4, 6. You can use your calculator to help you if you need to as well. This would be negative 2, 2. And this would be negative 4, 2. X double prime, y double prime, z double prime. So negative 4, 6. Everything should be 2/3 the distance closer to the origin now. Negative 2, 2. And negative 4, 2. So our shape should be smaller. We're multiplying by something less than 1. Shape should be smaller. Okay? That's what you're doing with that. Writing these details out, that's going to be helpful, help you keep those points straight. Okay, going the other direction. It says, describe a similarity transformation that maps the pre-image to the image. Okay, this is going to be a combination of 2 of them. 2 or more. That's just going to be 2. So what you notice here is you can use translations, reflections, rotations, and dilations to try to get this one to this one. Okay, so sometimes it works to go this way, and sometimes you want to think about going backwards, but your transformation should go from here to here. One thing I notice is this side, you want to look at corresponding sides, 1, 2, 3, 4, 5, 6. This has a side length of 6. This has a side length of 3. That is half that width. So at some point, since we're starting here, this is our pre-image, at some point we're going to have to do a dilation of a half. This was 2, and now this is 1. Notice these are orientated pointing in the same direction, so that we won't have any reflection or rotation or anything here. So if we start with a dilation, okay, and this is where sometimes pencils are going to come in handy. If we start a dilation and multiplying by a half, everything gets half the distance closer. So this n would go, this is up at 2, 3, 4, 5, 6. So this n is at 6. It's going to go right there. This one would go right there. This one is going to be half the distance. That'd go right there. So if we apply that dilation right now, it's going to go right, it's going to put the image right here. everything goes to half. And again, write it out. N is at 0, 6. That would put n, my new n, at 0, 3 if I have 1/2 x, 1/2 y. L was at 6, 6. My new L, if I apply it, was going to be at 3, 3. Now, if things are positioned pointing in the same direction, then you can do a translation to get it going in the right way. So we're going to have a dilation, and we're going to say xy goes to 1/2 x, 1/2 y. And now I need to translate down 1, and 1, 2, 3, 4. Down 1 and over 3. So I look at my corresponding points. This is my n, remember, is up here. This is my n. I have to go down 1 and match it up with that. So we're going to do a translation. I'm going to say xy goes to x, 1, 2, 3, 4, x plus 4, y minus 1. Okay? That is your similarity transformation going from here to here. That's how you know they're similar, because you can do those steps to make it happen. Okay, on number 5, notice here A and B is on the right side of your image. A and B here is on the left side of your image. So there's a reflection that's going on. Now, since we're starting here, I'm going to start by doing a reflection over the y-axis. So I'm going to reflect it over the y-axis, keep everything else the same. So here's my A, B, and C. Now my shape has gotten bigger, so I'm going to count 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is 4 over here, and this one is 2. And that seems to match along the bottom. The bottom is 4, this one is 2. So if I take everything times 2, I want to see what happens. So right now, C is at 1, 1. If I take it times 2, I get 2, 2. Okay, that matches up with where that C is. B is at 3, 1. If I take it times 2, I get 6, 2. Okay, that seems to match up where it's at. I think we're going to be okay. A is at 3, 3. Take it times 2, you get up at 6, 6. So we have a reflection over the y-axis, and then we're going to dilate, or dilation, we're going to say xy goes to 2x, 2y. Okay, the final one here, I have RSTQ, and notice where the RSTQ, you see how RS is going up and down on this side, and RS is going left and right on this side. That means we have some sort of rotation going on. We've got to get it rotated this way. If you take this image and rotate it down, it's going to happen here. So we're going to rotate 90 degrees counterclockwise. Rotate 90 degrees counterclockwise. So the T is going to go down here. The S, okay, you can use the rules here. So S is at 3, 6. That's going to put it at negative 6, 3. There's the S over there. R is at 3, 3, so that's going to be a negative 3, 3. That look right? Yep, looks about the same size. We haven't done a non-rigid. That's a rigid transformation. Should say the same size. Now look right along down here. This length, this is TQ now, that has a length of 3. My new one has a length of 1. So we're reducing it. We're dividing by 3. That means we're multiplying by 1/3. So since it is 1/3 the size, it has 1 out of the 3 that we had. So we have a dilation. We want to take xy into 1/3 x, 1/3 y. That means there should be 9 of these that would fit into our big one. So those are the similarity transformations. So those can be kind of tricky at times, figuring out what steps did they get to get there. Don't be afraid to try something. Work out some numbers, work it out, figure it out, and if it doesn't work the first time, just keep working at it. You'll get it. Stay positive. Keep working at it, and you'll be all right. So we'll see you in class.